Yeah, so I think it's important to note that
You-
the quantum computers are not going to replace classical computers anytime soon. If anything, they're going to be like a coprocessor, kind of like GPUs are a coprocessor for regular classical
uh,
computers.
in tandem, that's
And
No, yeah, I've never.
the lowest hanging fruit for quantum computers and something that we're working on is generically speaking combinatorial optimization. And what is combinatorial optimization? So combinatorial optimization aims at solving some of these algorithms that are considered to be way too hard for classical computers to compute. And one of those algorithms is one of those problems is this traveling salesman problem, where you have to find the optimal route for a traveling salesman across 50 different states in the entire country. Well, when you have 50 states that you have to find the optimal route to, that turns out to be a combinatorial optimization problem, or a total number of routes between those 50 states of like 10 to the 60th, right? And there's 10 to the 81st, or sorry, 10 to the 80th particles in the known universe. So this just gives you an idea of the scale of the problem. And so classical computers today, either they use something called heuristic methods, which is just a fancy name for a best guess, or some of these problems have just humans in front of a computer screen that are frantically trying to, map the most optimal path between point A and point B. And you have to do this in 15 to 20 minutes or in like breakneck speed. So some of these problems that computers can't solve, humans are still solving, and obviously this is suboptimal.